Hello and welcome to Biorules video lessons. Today we are going to see how evolution works. Okay, we are going to see how it happens. So, evolution is change in the gene pool. Ultimately, it's the change in the frequency of the alleles that you have in a certain population. So, if all organisms have genes that make them to be white, like this pepper moth over here, how a black one can appear? How is it possible that suddenly you have, oh look, this one is a black pigmented moth? So for this here to happen, something called mutation will happen. So a mutation is a change in the genes, a change in the DNA that leads to a change in the codon, that leads to a change in the protein, that it's been coded, and ultimately that's going to be changing the phenotype. The phenotype is the looks. In this case here, now it produces a darker pigmented moth. So they were lightly pigmented, or this light with a little bit of black spots, and now it's a very black moth. So the appearance of this variation, of this difference, happens by mutation, happens by a mistake in the DNA, that a mistake there in the gene that will make it to be different. So mutation in the whitish moth made it to overproduce melanin. So the one on the right, it's still a whitish moth, but now it's producing more melanin, so it's not whitish anymore, so now it's a darker one. So mutations create variation. So variation, it appears by mutation. Okay. It's the event that's going to be causing a change in the phenotype. For you to have one looks different to the other, no. So when we think in a characteristic like the wing color, no, we have there that they can be lighter or can be darker. If we get a hypothetical situation that all individuals have a gray wing, suddenly you may have mutations that may make to be a little bit darker or may make them to be a little bit lighter. So anything can happen. So mutations in the color of the wings can go one way, can go the other way. So this is how it's going to be happening. If you have characteristics that have a continuous variation, you have no phenotype variation, you have some light, some dark. This may have happened because of mutation. Some mutate to be dark, some mutate to be lighter. So mutation creates difference in the phenotype, but they create them very slowly. One mutation here, another one mutation there. It's estimated that every time DNA is copied, one mistake is made, one letter mistake. That can be anywhere, and even in places that are not going to be changing anything. So mutations are very, 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 very occasional, and they are random. They can go anyway. So you can have there, for example, certain characteristic that's medium gray color over there, and they may suffer mutation to make it darker or to make it lighter. So mutations are unpredictable. They are rare events, and they happen once in a while. So there is one other thing for sexually reproducing individuals, which is, quite to be honest, the vast majority of organisms on the planet, that is sexual reproduction. And this also has to do with something with variation, because it mixes up genes. Now, mutations that show up in one side of the population suddenly can be mixed with mutations in another side of the population. So you mix maternal and paternal genes. And because of that, in meiosis, because we have independent assortment, this mixing is totally random. So the chance for going one or going the other is totally random. And it's even more than that. If you have the crossing over, it makes it even more random. We see this here when you study genetics. And the idea is that mutation will create variation. So the variation shows up because of mutation. But sexual reproduction boosts up variation. It increases variation because it mixes stuff around two different genders. Between paternal and maternal genes, they get mixed up together. So both actually act together to promote variation. Mutations create variation, sexual reproduction increases variation. So there's a third phenomenon called natural selection. This is the key for what we know nowadays as being the evolution. Now, natural selection happens because organisms tend to overproduce offspring. So that means that every organism that reproduces tends to produce more offsprings than the environment would be able to support. So we have too many individuals. And if you have too many individuals, we are going to end up having a struggle to survive or a struggle to reproduce. Actually, and a struggle to reproduce. Too many, not everybody will be able to survive and not everybody is going to be able to reproduce. So as a result, then we ask, who is going to be surviving? Who is going to be reproducing? Few of them. So in this case, it's going to be the survival or reproduction of the fittest. The original sentence was from Charles Darwin, the survival of the fittest, the idea that only the fittest would survive. But nowadays we say the survival or reproduction of the fittest, because you need to survive and to be able to pass on your genes. By the way, Charles Darwin is considered to be the father of evolution, but actually no. Charles Darwin, evolution was already something that many scientists studied and discussed 2 generations before Darwin. Darwin's grandfather was already an evolutionist. What Darwin came up with, and not alone, Darwin and another guy called Alfred Russel Wallace had the same idea independently on natural selection. So basically, they figure out the mechanism that would allow evolution to happen in a certain direction. Not only having change by mutation that's totally random, but you having evolution going in a certain direction, being directional. And what they came up was with a mechanism that could explain evolution biologically to happen, and then they became the guys that explained evolution. Darwin got more famous because he had came up with the idea before, but both published it together. So because Darwin had the idea before, he had a much wider and broader set of examples and a ready text. So he became much more famous. So Darwin and Wallace are the guys that came up with the idea of natural selection, the survival and reproduction of the fittest. Okay. Let's go back to the example on having simple variation, light colored or dark colored, and we are not even going to be having here a gradient of colors. We have only 2 colors here, being light or dark. Let me speed this up for you. And you have this over there. Let's say you have a variation in a population, and in this example here, half the moths are lightly colored, half the moths are darkly colored. But if these moths live in this kind of background that you see over there, which one would be found by birds in an easier way? Which one would be more predated by birds? And if you said the dark ones, yes, you're right. Some lights would be caught, especially when they are moving, and many darks are going to be caught because they're not going to be so well camouflaged. This is actually what happened in the Industrial Revolution. Okay? In this example, light color moths survive, so the population have changed. It was 50-50, and now the population is mainly whitish. This was the population of pepper moths before the Industrial Revolution in Europe, especially in England, where they have been studied. Before the Industrial Revolution, the pepper moths were whitish because the lichens on trees were whitish. So they managed to hide themselves very well over there. But the Industrial Revolution brought 2 problems. 1, dark smog that darkened the trees. And 2, pollution, air pollution, that killed the lichens. As a result, the background became dark. And then the dark-colored moths started being less killed, the white-colored moths started being more killed, so we had a change in the population. Okay, so this is natural selection. Okay, predatory birds, they act selecting the moths. In that example, they were selecting the white moths in favor, so they survived and they reproduced. So we had there different colors of moths, as we put over there. Light ones are selected positively, so they are favored, while the dark ones were selected negatively. Don't say they are selected, but they have to say selected positively or selected negative, selected in favor, selected against. This is what happened before Industrial Revolution. Light ones were selected positively, they reproduce more, they leave more offsprings, and they multiply, so the population became lighter. So, lighter moths before Industrial Revolution. After the Industrial Revolution, what happened was that there was a change. The moths became darker. They simply evolved. Not that the pollution didn't make the moths to be darker. The pollution killed the lichens, the pollution made the trees to become darker with smog, and the pollution allowed birds to select the black, dark moths in favor and the light ones negatively. So it changed the overall proportion of the population. There is a simulation that you're going to see in a while, but before the simulations, let's put back things together. Mutations create variation. Some people say that this is the fundamental part of evolution. Without mutations, there is no evolution because there is no initial change. Sexual reproduction is not necessary, but it's very efficient in boosting variation, promoting variation. Variation is fundamental for evolution. And finally comes natural selection. Natural selection reduces variation in a certain direction. So it reduces variation, pushing things to a certain direction. In the case of the Industrial Revolution, the natural selection pushed the variation that was mainly white, very few darks, toward the dark spectrum. So it pushes evolution into a certain direction. Okay? In this stop here, there are many things for you to be able to do, to define evolution. We saw before, evolution's change, outline evidence for evolution, discuss fossil, selective breeding, artificial selection, homologous structures, convergence, whatever. Okay, you should be able to state that the population tends to produce more offsprings than the environment can support. This is the basis for natural selection. Now, you should be able to explain how this overpopulation leads to a struggle for survival, and state that the species, they show variation. Discuss how this variation come up with, the sex promotes variation, meiosis, and so on. Natural selection pushes evolution to happen. Explain how it happens, and explain two examples. Superbacteria, that we are going to see in another class, and pepper moths that I briefly showed you before, and you're going to see in a simulation in a while. Okay, so let's go for some examples here. The first one, with this one is mandatory, is for you to try to take a look on the pepper moth simulation. Basically, if you go to this website, or if you take a look on this link here, this QR code, you are going to be able to see the simulation. This simulation shows beautifully the idea of natural selection on the pepper moths. Before Industrial Revolution, when England had many lichens that were whitish, selecting positively the light-colored moths, and after Industrial Revolution, when the trees became darker. Okay, there are two other examples. This one here with rabbits is quite interesting, because in this one you can see, you can try to play with the color of the fur, with the food, with the environment. So there are many things here for you to play. You also have here a QR code if you want to play. And this one, this last one here, is quite interesting because it's about birds. It's an island that has some birds. You choose the characteristics of the bird. You can choose the size of the bird. You can choose the color of the feathers, and you can choose the beak to start your populations with. And then you have evolution happening by natural selection. There is mutation once in a while, and there is selection also working on those populations. So I strongly suggest you go to the first one. That's a mandatory one. Take a look, because you need to explain an example of evolution. The pepper moth is a great one. Actually, the pepper moth is quite interesting, because what's happening nowadays recently in the last 30 years is that air quality is getting better in England. So the tree trunks that were not white, that were dark, and favored the dark moths, now is going back to original. The air is cleaner, more lichens. So we are seeing evolution going back into the direction of light-colored moths again. There is even a movement in England saying, save the dark pepper moths, because they are suffering, because we are cleaning the air. But that's nothing that we can do if we want to have a clean air to breathe in. Okay. Now, after you do the simulation, take a look on this quiz so you can check out to see how much you learned from this lesson. I see you in the next class.